Hello, welcome back once again. Today we have a very interesting problem, right? We have negative 1 to the power of 1 all over 4. We're going to evaluate this without any calculating device. Mind you, we're here for just the fourth root. Is that the same with the fourth root? Yes, of course, right? So we just need the principal fourth root of negative 1. And we're expecting only one solution. If you get more than one, you're on your own. This is just like a problem like this, and people seems like getting a different thing. For example, we are asked, what is the square root of 4? Most people say that it is plus or minus 2. Yes, of course, we know plus or minus 2, when both are squared, it will give us 4. But if you answer this, you are just 50% correct. You know why? The square root of 4 is asking you for the principal square root, which must be positive, right? And that is plus 2. Just that. When you have plus or minus 2 is when we have this kind of equation where x squared is equal to 4 or x squared minus 4 is equal to 0. Here we have that x must be plus or minus 2. You get it? So the square root of 4 must be just 2 and not plus or minus 2. I think this will help us, right? And today we're going to find the fourth root of negative 1. And in this video, I'll be presenting two different methods. Okay? So let's begin with the first one. For the first one, we're going to call upon the great mathematician Leonhard Euler, right? His awesome looking identity. We have that the e raised to the power of I theta is equal to cosine of theta plus I sine of theta, right? So, but how can we use this to solve this problem? Is that related to what we're saying? The answer is no. But we can make this to look somehow related to this. Okay? So let us recall again from Leonhard Euler that e raised to the power of I pi is just equal to negative 1. I think this is the most beautiful equation in mathematics and science. Okay? So we're going to use this to write the base here. So with that, we're going to have our negative 1 to the power of 1 over 4 to be equal to e raised to the power of I pi, then raised to the power of 1 over 4. And from here we multiply these powers together, we get e to the power of I pi divided by 4. Then you can see that this is related to this, right? So we can use that now to write in terms of cosine and sine of angles, right? Okay, so this we can write this as just e raised to the power of, we have I, then we have just pi over 4, right? So here our theta will be pi over 4. And with that reason, so we can say that negative 1 to the power of 1 over 4 is equal to the cosine of pi over 4 plus I times the sine of pi over 4. So this will be equal to the cosine of pi over 4 will give us the square root of 2 divided by 2 plus I. Then the sine of pi over 4 will still give us the square root of 2 divided by 2. Wow. So just now, under few seconds, we're able to find the fourth root of negative 1, which is equal to square root of 2 plus I times square root of 2 whole divided by 2. And it is indeed positive, but a complex number, right? Is that not good? That is good and also cool. So let's go to the second method. For my second method, we're going to call negative 1 to the power of 1 over 4 x, right? And when we raise both sides to the power of 4, right? So we can see that this will cancel this. And from the right hand side, we have x raised to the power of 4 will be equal to negative 1 from the left hand side. The negative 1, take it to the left hand side, that will become x raised to the power of 4 plus 1. Then this is equal to 0, right? Now let us think about this. Okay, So we can rewrite this as x squared squared, then plus 1 here is 1 squared. So this is equal to 0. Let us record this identity. We have that a squared plus b squared plus 2 times a times b, that this is equal to a plus b whole squared. So it is a perfect square, right? So let's begin with this. We know that we have something squared here plus another thing squared. And look at this equation at the left hand side. This is squared and this is squared. So we need 2 times the product of the bases, right? So that would be x squared squared plus 1 squared. So we have plus 2 times the product of the bases, x squared times 1. Oh, yeah, of course. So x squared is the base here, y1 is the base here. Then to balance the equation, we need to subtract 2 times x squared times 1. So this is equal to 0. You get the idea? It is awesome, right? So from here is a perfect square. We can write it well as x squared squared plus 1, right, squared, plus this will be 2x squared. Then we have minus 2x squared. So this is equal to 0. So this here is a perfect square, which is x squared plus 1 whole squared. So minus 2x squared, this will be equal to 0. But how can this help us? It will really help. We just need the difference of two squares formula. But wait a minute. This is not a perfect square yet, right? Because these two here should be written as something squared. So that should be root 2 squared, right? Putting it together with x squared, that will give us root 2 times x all squared. So we get x squared plus 1 whole squared minus, so this will be root 2 multiplied by x whole squared. So this is equal to 0. So let's call upon the difference of two squares formula. Namely, we have a squared minus b squared is equal to a plus b multiplied by a minus b. So use that idea. So this one here will become x squared plus 1 plus square root of 2 times x multiplied by x squared plus 1 minus square root of 2 times x. So this is equal to 0. So from here we have two equations. So either this one here is equal to 0 or this one here is equal to 0. So let's solve. We have the first x squared plus square root of 2 times x plus 1 is equal to 0. And we have the second here, x squared minus square root of 2 times x plus 1 is equal to 0. So solve this quadratically. Oh God, what kind of English is that? Is that correct? So never mind. So let's solve this using the general quadratic formula. So we get negative b plus or minus square root of b squared minus 4ac divided by 2a. So apply this formula, we get negative square root of 2 plus or minus square root of b squared is root 2 squared, which is 2 minus 4ac is 4, then divided by 2. So this one here will be the conjugate, right? So this is root 2 plus or minus square root of 2 minus 4 whole divided by 2. So from here we have x is equal to, so we have negative root 2 plus or minus, so this is negative 2 under the radical, which is I root of 2. So this is divided by 2. And from this side here we have root 2 plus or minus I root of 2 divided by 2. Oh, so here you can see we have the fourth root of unity here. All these are also solutions, right? If the equation were x raised to the power of 4 plus 1 is equal to 0. For this equation, all these are solutions. But what we need here is the principal fourth root of negative 1. Let's assume that we didn't start with the first method, which you already know that the answer is root 2 plus I root 2 divided by 2. What are we going to do from here? Like, how are we going to figure out the one which is the principal fourth root? Okay, so we're going to do that using the complex plane. Okay, so here we have the complex plane. So we have the imaginary here, which is the y-axis, and here we have the real, which is the x-axis, right? So we should know that the fourth root of negative 1 should be located at the first quadrant here. And we know at the first quadrant here, both x and y, they are both positive. Remember that this is in the form x plus I times y. So at the first quadrant here, x is positive and y is also positive. For the second quadrant here, x is negative, y is positive. For this third quadrant here, x is negative and y is also negative. And for this fourth quadrant here, x is positive, y is negative. So since we're expecting our positive principal fourth root, so it should be located here, where x is positive and y is also positive, right? So we get the idea now, so we can use it to figure out the one which is a solution. So let's write out the whole values. We have negative root 2 minus root 2 times I divided by 2. We have here negative root 2 plus root 2I divided by 2. We have here root 2 minus root 2I divided by 2. And for here, we have root 2 plus root 2I divided by 2. So here, both x and y, they are negative. Here, x is negative, y is positive. Here, x is positive, y is negative, but here, x and y, they are both positive. So this is our solution, right? So we can conclude now that negative 1 raised to the power of 1 over 4 is equal to root 2 plus I root of 2 whole divided by 2. If you want to check it out, when you raise this to the power of 4, this will give you negative 1. So this is our solution. Did you enjoy the video? Kindly support the channel by subscribing. Please do well to subscribe to the channel. Turn on the notification button so that you'll be notified whenever I upload my next video. Thank you.